Hello. Here is the video going over the free response practice for your second semester final exam. So the first question for your free response is going to be graphing and finding the intersection point. So we want to solve the systems of equations by graphing. So I'm going to go ahead and color coordinate. This will be drawn in purple. This one will be in blue. So both of those are in slope-intercept form, which is awesome because that helps me identify my slope and my y-intercept. So for my purple one, my slope is 3, y-intercept is 0, -1. They are both in slope-intercept form. So it looks like this, where m is your slope and b represents your y-intercept. So I'm going to go ahead and start graphing my purple line. I'm starting at 0, -1. Slope is 3, so I'm going to go up 3 over 1, up 3 over 1. I'm going to go ahead and continue in both directions so I can draw my first line nice and complete. So there is the first one. For my second line, which again I'm doing in blue, my m is the number in front of x, which is -1, and my b is 7, so my y-intercept is at 0, 7. So I'm going to start at 7. Slope is -1, so I'm going to go down 1 over 1, down 1 over 1, and look at that, we just found our intersection, since my blue dot went right on top of my purple one. So here is the intersection point, and that is going to be your solution to the system. So writing down that ordered pair is 2, 5. So there is your answer for number 1. Number 2 is a little bit more involved. I should say way more involved because you're doing a quadratic word problem. So at the end of the school year, Ms. Schneider cleans her office by throwing a box of all the extra paper and tests off the top of the nearest Aurora water tower. The path of the box can be modeled by this equation, where h of t is the height in feet and t is the time in seconds. I would love to throw a box of extra papers and tests off of something. That'd be so fun. But anyway, so you can solve the quadratic using any method. So you can use the quadratic formula, you can factor. I'm actually going to go straight to the quadratic formula because I have a feeling that most people would take this route. You do not have to. You can easily factor it, which I will also show you. If that's the route that you want to take. So A is -3, B is +15, and C is 18. So quadratic formula says -b plus or minus square root of b squared minus 4ac all over 2 times a. And I'm just going to go ahead and put my corresponding values in the correct spots. So -b, since b is 15, I can go ahead and replace my b's with 15. Same thing underneath the radical with that b squared. I'm going to do 15 squared minus 4 times a. A is -3. -3 is also on the bottom of your equation, so I replace that as well. And I do need my c because it's minus 4ac. So all of that is underneath the radical. So I have -15 plus or minus. I can take that expression and put it into my calculator. That's going to give me the square root of 441 all over -6. Square root of 441 is 21. So I have -15 plus or minus 21 over -6. Now at this point, to get my two answers, I can separate. So I have -15 plus 21 over -6 and -15 minus 21 over -6. That gives me -15 plus 21 is 6 over -6, which is -1. And for my second one, I have -15 minus 21, which is -36 over -6, which is +6. So my two values for t for this particular quadratic are -1 and +6. Like I said, I will show you factoring if you wanted to do factoring as well. I have -3t squared plus 15t plus 18 equals 0. I can go ahead and divide everything by negative 3 since they're all divisible by 3. That gives me a positive t squared minus 5t minus 6 equals 0. Now I'm trying to find two numbers that multiply to negative 6 and add to negative 5. So multiplies to negative 6, adds to negative 5. That is negative 6 and positive 1. Those two values are going to go in your parentheses. So I have t minus 6 and t plus 1 equals 0. Solving by factoring, we can use the zero product property where we set each factor equal to 0. And you will see that you will also get positive 6 for the first one and negative 1 for my second factor. So it's just up to you on which method you want to do. Some people are better with the quadratic formula. Some people are really quick with factoring. So whatever it is that you're going to remember. For letter B, for my x-intercepts, I'm just going to take my values of t that I got for letter A and write them as ordered pairs. So my first x-intercept is at negative 1, 0, and my other one is at 6, 0. Next up, finding the vertex. So finding your vertex is done in two parts. The first thing you need to do is you need to find the x-coordinate of your vertex. And that you're going to use this little formula, x equals negative b over 2a. So again, a is negative 3, b is 15, and c is 18. So I'm going to take negative b, so negative 15 over 2 times a. That gives me negative 15 over negative 6, which in the calculator I can go ahead and reduce to 2.5. So that's going to be my x-coordinate. For my y-coordinate, what you're going to do is you are going to take your x-coordinates, so this value of 2.5, and you're going to plug it in. So you're going to plug it into the original function, so negative 3, but instead of t squared, I'm going to do 2.5 squared plus 15 times 2.5 plus 18. You can go ahead and put all of that right into your calculator, and you get y equals 36.75. Your vertex, of course, is a point, so we write it as an ordered pair. X-coordinate was the 2.5. Y-coordinate is the 36.75. So there is your vertex. Your y-intercept you calculate by plugging in 0 for x. So I have y equals negative 3 times 0 squared plus 15 times 0 plus 18, and all of that's going to simplify to 18. So your y-intercept is 0, 18. Okay, so now that all of the calculation parts are complete, we can use these pieces of information to answer the rest of the questions E through I. Now, before I start answering those questions, I'm actually going to sketch a graph of this parabola just because it gives us a context for me to explain where these answers come from. So my y-intercept was 0, 18, so I'm just going to plot a point somewhere right here. We'll label this 0, 18. That was my y-intercept. Your vertex is at 2.5 and 36.75. So 2.5, I'm going to say 36.75 is about right here. It's just an overall sketch. You have your x-intercepts at negative 1, 0. So that's this one over here, and positive 6, 0. So 1, 2, 3, 4, 5, 6. Okay. So here is a sketch of what's happening to that box that's being thrown off of the Aurora water tower. Okay, so at what time does the box reach the maximum height? So I can see my maximum is right here. So your vertex actually gives you two pieces of information. It tells you the time, and it also tells you the height. So at what time does the box reach the maximum height? You are looking at your x-coordinate of the vertex. Don't forget your units, of course. So this is 2.5 seconds. Now, what is this maximum height of the box? So that maximum height comes from the y-coordinate of your vertex. So both E and F come from the vertex. My maximum height was at 36.75, and that is in feet. How many seconds does it take for the box to hit the ground? So it's going to hit the ground at this point over here, and that was our x-intercept of 6. So I'm just going to make a note. This is our x-intercept, and that is 6 seconds. Okay. Now the domain. So your domain are possible values that you can have for your time within this scenario. Now you can't really have negative time. So really the valid portion of our graph goes from here to here. So I'm going to use that to be able to establish my domain and range. So your domain is basically what is happening to your t values. Well, the lowest t value that I can have is 0 seconds, and the highest value I can have is 6 seconds, because that is when it hits the ground. So for my domain, it's going to be 0 to your positive x-intercept. Now you can write your domain and range in two different ways. You can write it as interval notation, which is what I did, and I incorporated brackets because 0 and 6 can actually be used for values of time. Or you can write it as an inequality. So your inequality would be 0 is less than or equal to your t for time, less than or equal to whatever your positive x-intercept is. So if I wanted to write my other possible answer for my domain, this would be 0 is less than or equal to t is less than or equal to 6. Does mean the same thing though. Your range are your possible values for your height, since your y values are talking about your height. The highest your graph goes, or the box goes, is at 36.75, and the lowest your box goes is at 0, because that's when it hits the ground. So my range goes from 0 to 36.75. So I was starting to write in blue my little hints. Your range is going to go from 0 to your maximum height in this particular context. You could also make a note that it's 0 to your y-coordinate of your vertex, if you want to, but I think maximum height makes the most sense. And again, you can write this as an inequality. So I have 0 is less than or equal to h of t, because that represents your height, is less than or equal to your maximum height. So with the actual numbers, this would be 0 is less than or equal to h of t is less than or equal to 36.75. All right, so that covers your questions for the free response portion of the final exam.